In this lesson, we're going to look at the idea of a discrete random variable. We're going to look at different ways of displaying the information, such as in a distribution table, as a distribution function, a cumulative distribution function, or as a graph. And we're also going to look at how to calculate things such as the mean, mode, median, and measures of spread. So a discrete random variable is a variable where the outcome is random and can take discrete values. For example, the outcome when you roll a dice. This would be different to a continuous random variable where the outcomes would be continuous things such as lengths or weights and so on. First of all, we're going to consider the outcomes when we take two four-sided dice and roll them. The discrete random variable x is going to be the result that we get when we add the two scores together from the dice. We want to show the probability distribution of x in 4 different ways. So to start with, we're going to consider all the possible outcomes of rolling these two dice and adding the scores. So the easiest way to do this is to draw a sample space diagram. So we see we can get 1, 2, 3 or 4 on the first dice and 1, 2, 3 or 4 on the second dice. So adding together those scores gives us this sample space, and we can see that some scores come up several times. For example, 4 comes up 3 times. So we can use this to calculate the distribution of the probabilities. So a distribution table would have the x values across the top. These are all the different values that x can take, remembering that x is the sum of the two scores. So from this diagram we can see that x could be 2, 3, 4, 5, 6, 7 or 8. We then write the probability of x taking each of those values underneath. So the probability that x equals x. Notice we've used a capital X for the discrete random variable and then a lowercase x for each of the different values that x could take. So filling this in, we can see, for example, there is only 1 2 out of the 16 outcomes, so the probability of getting a 2 is 1 over 16. Whereas, for example, there are 3 4s, so the probability of getting a 4 will be 3 out of 16. So that is a distribution table for x. We can also show this information in other ways. For example, we could write a distribution function. This is where we write the probability that x equals each of the x values, and then we use a curly bracket to write down the different outcomes. So x could be 2 or 8 with a probability of 1 over 16. So we've picked out the two events where the probability is 1 over 16. We then take the next probability, which is 2 over 16, and we see the corresponding x values for that probability are 3 and 7. The next probability is 3 out of 16, and that is when x is either 4 or 6. The probability could be 4 over 16 in the case where x is 5. So we've listed all of the possible probabilities in the table. However, we need to remember to put the 0 probability for any other value of x. So any value of x that isn't 2, 3, 4, 5, 6, 7 or 8 will have a 0 probability. So we say 0 otherwise. Next, we're going to look at a cumulative distribution table. This is where we add up the probabilities as we go along. So the x values can take 2, 3, 4, 5, 6, 7 or 8. And this time it's the probability that x is less than or equal to that x value. So all of the probabilities up to and including that x value. So up to and including 2, probability is just a 16th. Now up to including 3, that is 2 and 3. So we need to add together the two probabilities, 1 16th and 2 16ths to get 3 16ths. The probability that x is less than or equal to 4, that means 2, 3 or 4. So we're going to add together these three probabilities to get 6 over 16. And we keep going. So to include 5 in this, we need to add on the probability for x is 5. For less than or equal to 6, we need to add on the probability for 6. And less than or equal to 7. And finally, less than or equal to 8. Now, because we have now included all of the values x can take, this last cumulative probability should be 1. And finally, we can display the information in a graph or a bar chart. We put the probabilities up the side, and we choose the x values along the bottom. Now, because this is discrete, we're going to leave gaps between each of the bars. And we just draw the probability of x taking each of those values. Now pause the video and have a go answering these 4 questions. So for the first 2, you've been given a distribution table and you're being asked to draw the distribution function. You will need to find the missing values of k to do this. And for the bottom 2, we've been given a distribution function and we want to put this in a distribution table. So pause now and answer this question. Okay, so for question 1, we first of all need to find the missing value of k. We know that the probabilities need to add up to 1 altogether. So in this case, the value of k will be 1/10. We can now draw a distribution function. Probability that x equals x is, and we need to list each of the probabilities, remembering that if there are 2 probabilities the same, we write those together on the same line. So first of all, the probability would be 1/10 if x was 1.1. It would be a quarter if x was either 3.4 or 4.8. It would be 2/5 when x is 6.0, and it would be 0 for any other value, so otherwise. Okay, so for question 2, we can see here that in order for the probabilities to add up to 1, 2k must equal 0.1, so k must equal 0.05. We can now draw the distribution function, and we can list each of the probabilities and the corresponding x values. So probability that x equals x would be 0.2 when x is 2, 0.05 when x is either 3 or 4, 0.5 when x is 5, and 0 otherwise. For question 3, we're now going to work the other way, start with the distribution function and draw the table. And we can see here that x will have a probability of k for these 4 x values. So it's the same probability for 0, 2, 4 or 6. It will be 0 for any other value of x. So because there are 4 values of x and they're all taking the same probability, k must equal 1/4. So we can now fill in the table with the x values listed here, 0, 2, 4 and 6, and we can give them all a probability of 1/4. Notice that we didn't need to put the 0 otherwise when we were in a table. For the 4th question, we have been given a formula here for finding the probability for these 3 x values. So when x is 1, the probability will be found by substituting x equals 1 into this. So 2 over 3 times 1 squared, the probability will be 2/3 when x is 1. To find the probability for x is 2, we would substitute 2 in for x. So we would get 2 over 3 times 2 squared. This would be 2 over 12, or 1/6. And for x is 3, we'd substitute 3 in here to get 2 over 3 times 3 squared, which is 2 over 27. We then know that there is a probability k when x is 4. So we need to add up the 3 probabilities we just found, 1, 2, and for 1, 2, and 3, and whatever is left to make 1, that will be the value of k. We can then put these values into a table. So when x is 1, we substituted 1 into the formula and we got 2/3. When x is 2, we substituted 2 into the formula, which gives us a probability of 1/6. For x is 3, we substitute 3 into the formula to get a probability of 2 over 27. And then for x is 4, we need to add these probabilities up and subtract from 1. This leaves us with 5 over 54, so that is the probability for x is 4. We're now going to use these tables to calculate the following probabilities. Again, pause the slide and have a go at the questions first before you continue. So for question 1, we want to know the probability of getting more than 3 in this discrete random variable. So here we can see that of the possible values of x, 1.1 is less than 3, but the other 3 values are all more than 3. So we can add together the probabilities of the 3 values of x that are more than 3. A quarter plus 2/5 is going to give us 9/10. Alternatively, we could have done 1 minus the one remaining value, 1 minus 1/10, which would have also given 9/10. Next, the probability of getting at least 4. So at least 4 means 4 or more. So that is either 4 or 5 in this table. So we add together the two probabilities for x is 4 and x is 5, and we get 0.75. For question 3, we want the probability of getting at most 2. So at most 2 means 2 or less. So that is either 2 or 0 in this case. So we add together the probabilities for 2 and 0 and we get 1/2. And in question 4 we have probability that x is greater than 2. So greater than 2 is these two values here, 3 or 4. So if we add together the two probabilities, we get 1/6. We're now going to calculate the mean, median and mode of x for this probability distribution for this discrete random variable x. So here we can see we have the values that x can take and the probabilities that it will take each of those values. We want to know what the mean value would be first of all of x. So the mean, sometimes we use the Greek letter mu for mean, is also sometimes known as the expected value. So expected value and mean both mean the same thing. We often use the notation EX. So E of x means the expected value of x, which also means the mean of x. This is the formula. The expected value of x is sigma xi pi. What this means is that for each of the x values, we multiply the x value by its probability, and the sigma means that we add all of these values together. So in this case, we are going to go along the table, multiply each of the x's by their probability, and then add together the answers. This will give us the expected value of x. So in this example, we're going to calculate 3 times 0.1, 4 times 0.15, 5 times 0.2, 6 times 0.35, 7 times 0.2, and add each of these values together. This gives us 5.4. So 5.4 is the mean value of x. Now we want to find the median of a discrete random variable x. Now we know that with a list of x values, we know that the median would be the middle number if they were in order. In order to find it for a discrete random variable, we need to do two calculations. We need to find the x value, so the probability of x being less than or equal to that value is either equal to 0.5 or above 0.5, but also the probability of x being greater than or equal to x is also greater than or equal to 0.5. So we're essentially trying to find a point that's as close to the middle as possible, the probability being as close to 0.5 on each side as we can. So we're going to need to use the cumulative probability distribution for this. Remember, the cumulative distribution, you add up the values. So first of all, we're going to work out the probabilities that x is less than or equal to each x value. So less than or equal to 3 is just 0.1. Less than or equal to 4, we're adding up the two values here for 3 and 4. So probability is 0.25. Less than or equal to 5, we are now adding these three values up. 0.45. The probability of being less than or equal to 6 is 0.8, and probability of being less than or equal to 7 is then 1. So adding up from the left hand side, these are the cumulative probabilities of x being less than or equal to that value. We need to go until we are just past halfway. So we want the least value of x such that the probability of x being less than or equal to that value is either equal to 0.5 or above it. So we go along, the probability of x being less than or equal to 3, less than or equal to 4, and less than or equal to 5, they're all less than 0.5. Now less than or equal to 6, that's the first value where the probability of x being less than or equal to that number is more than 0.5. So from this side, from the left-hand side, we get a value of x equals 6 for the median. However, we now need to go from the other side to check if we get the same value. So we now need to do a cumulative distribution table for probability of x is greater than or equal to x. So we're going to start from the other side this time and add the probabilities from here. So greater than or equal to 7 is just 0.2. Greater than or equal to 6, that means 6 or 7, so we add together those two values, 0.55. Greater than or equal to 5 is now these three values here added together. Greater than or equal to 4 is these four values. Greater than or equal to 3 is then all 5 of the values added up, which is 1. So we've now got the cumulative distribution, but from the other side, so greater than or equal to x. We're now going to do the same process, but from the other side. So we're looking for the greatest value that satisfies this inequality here, that the probability of x being greater than or equal to that value is either 0.5 or more. So we get 0.2. We then get 0.55 for x equals 6. So this is the first value where we have gone past 0.5. Now, because we've got the same value of x going from the left and from the right, we can conclude that the median of this discrete random variable is x equals 6. We're now going to look at what happens when we try to find the median if we get two different x values, one from the left and one from the right. If this does happen, this is equivalent to when we have two values in a set of data where we take the midpoint of those two values for two in the middle. So we're just going to change the values slightly in the table so that this works. So we've now got, we've changed the value, the probability of x being 5 to 0.25, the probability of x being 6 to be 0.3. So this is a slightly different table to the last example. So the cumulative values for x is less than or equal to x now adds up to 0.1, 0.25, 0.5, 0.8, 1. So going from the left-hand side to find the least value that satisfies the inequality, we can see that x equals 5 satisfies this because the probability is equal to 0.5 there. Now going from the other side, if we calculate the probability that x is greater than or equal to each value, we get 0.2, 0.5, 0.75, 0.9 and 1. And finding the first x value such that the inequality is satisfied, we get x equals 6. So you see we get different values of x depending on which side we go from. So the median will be between 5 and 6, so we take it as 5.5. The mode of a discrete random variable is the value of x that has the greatest probability, in other words, the most likely one to occur. So we look in the table and we see that x equals 6 has the highest probability of 0.35. It's more likely than all of the other outcomes, so the mode is 6. Discrete random variable can have more than one mode if you have the same greatest probability. If all of the outcomes are the same, if the distribution is uniform, we would say there was no mode. Now pause the video and for each of the 4 discrete random variables, calculate the mean or expected value, the median and the mode. When you've got the answers, continue. So for question 1, we have a mean of 4.56, a median of 4.8 and a mode of 6. Question 2, we have a mean, median and mode here. For question 3, Notice that there's no mode for question 3 because all of the probabilities are the same. This is a uniform distribution. And for question 4, we're now going to look at the variance of a discrete random variable. The variance is a measure of spread. This formula here is often given as the variance, but an easier way to calculate it with a discrete random variable is as follows. We use var x to mean the variance of x, and it's calculated by finding the expected value of x squared and subtracting the expected value of x all squared. Now these two things are different. The second one is just taking the expected value of x, the mean that you found earlier, and just squaring it. The expected value of x squared means going back and recalculating, but instead of multiplying x by the probability each time, you multiply x squared by the probability, and then you add up each of those values. So these are two different things. So here we take each of the x's, square them and multiply them by the probability, add up these values, that gives us ex squared. Here we take each of the x values, multiply them by the probability and add them all up, and then square the answer at the end. So just be aware that those two things do not mean the same calculation. I'm now going to find the variance of this discrete random variable given in this distribution table here. We can then find the standard deviation from that. The standard deviation is just the square root of the variance, so that can be calculated after. So using this formula for variance, we're first of all going to calculate the expected value of x, which is the mean. So we're going to multiply each of the x values by their probability, add them all together, and we get an expected value of x of 5.4. Then to find ex squared, we're going to square each of the x values first and multiply them by the probability. So 3 squared times 0.1, 4 squared times 0.15, 5 squared times 0.2, and so on. Add those values, 30.7. And then finally, we're going to do the expected value of x squared minus the expected value of x all squared. So 30.7 minus 5.4 squared gives us a variance of 1.54. So the standard deviation is defined as the square root of the variance. So now that we have the variance 1.54, we can square root that, giving us a standard deviation of 1.24. Now pause the video, and for each of the 4 distributions, calculate the variance and the standard deviation using the formula on the previous slide. So the answers for question 1 are here. The answers for question 2. The answers for question 3. And for question 4. Now complete exercise 1A on page 257.